Thank you. This is a very important lesson on completing the square. This is used on SAT, ACT, high school teachers use it, and we use it because it works all the time. All right, so our methods for solving quadratic equations. We've learned quite a few. Number one, the square root method, where you root both sides. You should have been doing that last night. If you solved by factoring, that was an issue. You didn't learn that method. So when I test you on it, that could be a problem. But this doesn't work if I have a linear term like ax squared plus bx. Once you have that linear term, that b term, see, ax squared plus bx, it doesn't work for that. The graphing method, not very accurate. If I do not have integers for the roots, then it's hard to read. It's in between the lines. Does that make sense? And you have to eyeball things. In this particular case, it's at -1 and 3, but if it's not on a line, you have to eyeball it, so that's kind of difficult. The third method, the quadratic formula, probably one of the easiest. Once you learn it, it will probably be a lot of people's go-to method. It's very easy. That's why I wait till the end, because I want you to learn the other stuff. That's pretty easy. We figure out what's A, B, and C, and we substitute it into a formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. This always works. Factoring. We've done that for a little bit. But again, if the roots are not whole number factors, it only works when things are factorable. Completing the square. This always works, what we're doing today. Okay. So, completing the square. Ben, do you want to move? Okay, so the first thing we do when we complete the square is we have to get rid of the c term. Remember, it is ax squared plus bx plus c. Okay, we have to get rid of the c term, the number all by itself. How would I go about doing that? Zach? Add 7 to both sides. So I'm going to add 7 to both sides. I'm left with this. Now, my goal here is to create a perfect square trinomial. Perfect square trinomial. What number would go in there for a perfect square trinomial? David? Huh? No? Leora? Plus 9. Okay. Now, how we get that? Okay, how I get that 9 is really I always take my b. I divide it by 2, and then I square it. You guys with me? So b here is 6 divided by 2 squared. What is 6 divided by 2? And 3 squared is? And I can do anything to an equation as long as I do it to both sides. So if I add here, I have to add here. You with me? Now, we can factor this. If this is a perfect square trinomial, Leora? X plus 3. Do you guys know how to do that? Yeah. We take the square root of this one and the square root of this one and this sign. So it's x plus 3 squared equals 16. Now, I can always double check myself because x plus 3 squared really means this, right? So if I multiply this and this, I get 3x. And then double it times 2, 3x times 2, I get the middle term. Y times 2, because I have 3x here, and I have 3x here when I multiply. That's why it's times 2. Okay. All right. Now, is everybody clear where we're at? Yes. Adding 9, adding 9. Oh, I'm on the wrong clicker. Oh, it's in the middle, sorry. Okay, now that I have my quadratic alone, what do we do, Ben?
You square root it?
Yeah, don't be rude, just root it. Root both sides. Okay? And what is the square root of x plus 3, please? Zach?
The absolute value of x plus 3.
Equals what?
4.
4. To lose the absolute value, what do I have to do, Gabby?
Make the 4 plus minus.
Right? Make the 4 plus or minus. So now I subtract 3, and we're left with negative 3 plus or minus 4. That means this. Negative 3 plus 4 is? 1. And negative 3 minus 4? And so my solutions are negative 7 and 1. Usually we put them least to greatest. It doesn't matter. The only order that matters is function notation. Okay? Questions? Yes?
Oh, actually, I'll ask you later. I think you'll get it.
Okay. Okay, questions here. Yes?
Did we ever do homework for the negative b plus or minus the square root of b
No.
squared?
That's this quadratic formula.
But we never really
That's last. Okay. So, we know, what would this perfect square trinomial be? 9, right? And we know that it's this, right? I'm going to erase that. What does it factor to? Okay. Okay, I want you to notice this. What relation does the linear term have with this? Yes.
3 plus 3 is 6.
How do I get from here to here? Jada? I multiply 6 by 2?
No, you divide it by 2.
I divide it by 2. Okay, so what might this be right here? Gabby?
M plus 6.
M plus 6. So the relationship is I'm dividing by 2. I'm dividing by 2. The linear term. Okay? What about this one, m plus 6 squared? And then what do I do? So we know that this was a 9. So what relationship does this have with this? What goes in that little box, Audrey?
The square of 3 trace.
I'm asking what goes in this box here.
Oh, that one, 36.
36. Okay, so now number 3 and number 4 go. And number 5. Pause the recording, you do it on your own. All right, so now what does the number 3 factor to? I want to hear from some other people. Number 3, Nicole.
Is it negative?
I'm asking what does number 3 factor to? Notice this is m plus 6 squared. What's this going to be, number 3?
Is it negative 9?
Okay, do you notice this is a binomial every time?
Oh, yeah, y plus, I minus 9 squared.
The quantity of y minus 9 squared. So what would go into the box?
81.
Yep. Next one. Gohar. The quantity of k minus 7 squared and 49. Okay, did anybody get number 5? I want to talk about this. Remember I said when we have ax squared plus bx equals c, plus c? I said take the square root of that and the square root of that. Well, the square root of this is what? 2t. Now, Every time, what do I do to get this? So I got to divide this by 2 to get what this whole thing is supposed to equal. Do you understand? So 20t divided by 2 is what? 10t. So the whole thing's supposed to equal 10t. So what goes in there to make it equal 10t, Audrey?
25.
No, what goes in here to make it? You're close. Do you see? I'm every time I divide that middle term by 2, that becomes 10t. What do I have to multiply this by to make it equal 10t? Platty? Yep. 2t times minus 5 makes that 10t. Now, Audrey, what goes in here?
25.
Yes, that's where my 25 goes. Okay. Questions? All right. Completing the square. Here we go. So, step 1, what do we do? Derek. And it's not an option to do this. You may be able to factor later, but I don't want you factoring. You complete the square. Nicole.
Subtract 5.
Yep. Derek, I'm coming back to you. So get your head in the game. Okay, now, how do I complete this perfect square trinomial on the left? Derek? Huh? Factor it? I can't hear you. What? Don't tell him. I don't need you to whisper. Okay. How do I complete the square? Ben?
Divide 8 by 2 and square
We
it.
always, always, always divide b, the middle term, by 2. b divided by 2 and square it. And in this case, my b is 8. Negative 8 divided by 2 squared. What does that become, Derek? 16. So if I add it to this side, I have to add it to this side. What does the left side simplify to, Medrano?
Wait. What is it first?
What does the right side simplify to? 11. And what does, okay, positive 11. And how do I factor this side, Derek? X minus, because I have that minus there, I've got to have it x minus 4 squared. Now what, guys? Don't be rude, just root it. Now, I showed you this problem because I wanted to show you this answer. Now what? Leora?
To take away the absolute value, we will have to say plus or minus to the radical 11.
Okay. And now I add 4. Add 4. I'm going to just erase this and put the... I'm adding 4. I'm adding 4. And we get... Look at my solution. It's perfectly good with a radical as long as it's a reduced radical. If you need to estimate it because it's a word problem, square root of 11 is pretty close to, it's between 9 and 16. What's it closer to? 9. So can we say about 3.2? 4 plus 3.2, 7.2 about. Or 4 minus 3.2, about 1.2. Is this clear? Okay. All right. So everybody understands what to do with the radical. Okay. Next. You should be writing this entire example. All of these examples I have here for a reason. Slill, what would I do first?
You would subtract 6.
Good. Subtracting 6. And then I've got this. Now, how do I complete my square, Rachel?
You divide the b by 2.
And what's the b here? And look what we're going to do. It's an odd number, right? So I'm still just putting it over 2 and then doing what? Keep it in fraction form. Makes it very easy. So when I square that, what does it become, Ellie?
Negative 25 over 4.
No. Close.
25 over 4.
25 over 4. If I add it to one side, I have to add it to the other. This is the point where people make mistakes. They forget to add to the other side. Properties of equality. Next step. What would I do next, Daniel Ledman?
Next, you would factor it.
Factor. And so what is this factor to? Very easy.
It would be x minus 5 over 2.
5 over 2. Square root of this, the square root of this. Pretty easy, huh? And it's squared, the whole quantity. Now over here, you'll notice I have a denominator of 4. So I need a denominator of 4 here. In order to do that, I have to multiply by whatever that denominator is. You're multiplying by that number over itself, a fancy 1. So what does it become? Negative 24 over 4. Now, these two simplify to 1 over 4, and we already factored that. Next step, Jessica?
You put it in radical.
We have to root it. And so now look what I have. Absolute value equals, separate your radicals. You have to separate your radicals. Rad 1 over rad 4. What's the square root of rad 1?
1.
Okay? So, and the square root of 4? 2. So, I'm adding 5 over 2 plus or minus 1 over 2. 5 over 2 plus 1/2 is 6 over 2, which is 3. 5 over 2 minus 1/2 is 5 over 2 minus 1/2. 4 over 2, which is 2. Okay. Questions? Okay, if I don't have a C, nobody says I can't add a C. So I could solve this. I can solve any quadratic by completing the square. So I just add a C. Here comes the Amber Alert, sorry.
What is it?
Shh. So with this, I'm just going to go through this slide very quickly. My B is going to be, yeah. Divide by 2, square it. Okay, I'm just going through it quick. It's the same thing. The only difference is it had no C to start with. Is that too fast, or can we go? Okay, next one. Lead coefficient. Okay, we're going to start the same way. Get rid of our C. Step 1, add 4. Now, do we like lead coefficients? No, they're very ugly. Don't tell them I said that. I might get in trouble. Might get written up as a teacher for calling numbers names. They're very ugly. So we want to get rid of our lead coefficient because we don't like them. So I am dividing all terms by the lead coefficient. 2x squared divided by 2, 7x divided by 2, and 4 divided by 2. So what happens here? What am I left with for this term? X squared. And over here?
7 over 2x.
And here? Perfect. Now, how do I complete the square? Nicole?
Find the c.
Huh?
Find the c.
Find the C. How?
Divide by 2 and square.
Divide B by 2 and square it. 7 over 2 divided by 2. Okay, I'm going to just show you really quick. Okay, 7 over 2. I'm going to take a little sidebar, make some space off on the side. If I'm doing, okay, 7 over 2, that's my B, divided by 2. And aren't we squaring that, right? Isn't that the same thing as 7 over 2 divided by 2?
Right.
Isn't that the same thing? And when we divide fractions, how do we do it?
Multiply that over 2.
There we go. And the whole thing is squared. Okay? So now, what does it become? 7 over 4 squared. Now, Irene was telling me, like, you can just do outside, inside. So, right, this is 1. She said, oh, there's an easier way you guys learned last year. 7 times 1 over 4. Outside, inside, I think Miss Cacciatore taught you. So we are adding what to both sides? 49 over 16 plus 49 over 16. Okay, questions there? Does everybody understand what to do with that lead coefficient? And now we're factoring. X plus what? What is this?
7 over 4.
X plus 7 over 4. And I'm going to turn that 2 into 32 over 16, so it becomes 81. Ugly numbers become pretty numbers. Why is 81 pretty?
Because it's square.
It's a perfect square root. Yep. So don't be rude, just root it. Absolute value of 7 over 4 equals rad 81 over rad 16. So it's 9 over 4. And then I subtract my 7/4 from both sides. And I'm left with x is equal to negative 7/4 plus or minus 9/4. That's 2/4 or 16/4, which is negative 4/4. Negative 4, sorry. Are there any questions? Because we have so much time left. Okay, please check your homework at home. Also, test tomorrow. I've written up a little review sheet for the after-school group. If anybody wants to take a picture, you are welcome to.